This is video 1, Unit 9, Lesson 3. We're going to continue simplifying, and we're going to work on multiplying in this lesson. Radicals behave a lot like variables. So for example, we distribute with radicals like we distribute with variables. So if I were distributing this, that means I'll do 2x times x, that gives me 2x squared. 2x times 3 gives me 6x. Okay, so there's something we need to know about the radicals is that you can multiply numbers that are inside radicals together and numbers that are outside. This is multiplication. Okay, so this example, we will distribute the square root of 3. So square root of 3 and square root of 6, those are both under the radical. So I get square root of 18, 3 times 6. Square root of 3 and then 7, one is outside, one is inside. So I just have to write them next to each other. So 7 square root of 3. Okay, when I'm done, I have to check to see if anything could be simplified. So square root of 18, it can be simplified because 9 goes into it, and 9 is a perfect square. So then that's 3 square root of 2. And then I'll bring this 7 square root of 3 down. The final thing you'd want to see is if you have like radicals. If you have like radicals, you could combine. But square root of 2 and square root of 3 are not the same. So this is as far as I can go. Okay, let's look at the next one. So square root of 5 times 2 is 2 square root of 5. Square root of 5 times square root of 10 would be square root of 50. So since 5 and 10 are both under the radical, I can multiply those. Okay, 2 square root of 5, I can't do anything with that, but I can simplify square root of 50. $25 goes into it. So I have 2 square root of 5 plus 5 square root of 2. Those are similar, but they're still not like radicals. One is a square root of 5, one is a square root of 2. So this is also done. Okay. We have a few more. This time we're going to add in some variables. Two x and 6x are both under the radical, so I can combine those. I can multiply. 2 times 6 is 12. X times x is x squared. And then 11 is outside. Okay, I need to simplify this 12x squared. So first, what I do, I'm going to separate and then simplify each one. So 12, 4 times 3, which is 2 square root of 3. X squared is just x. And then I combine what's on the outside together, so 2x square root of 3. Okay, so those are all multiplying. And then let me bring down minus 11 square root of 2x. 3 and 2x are definitely not the same. So this one's done. Okay, here square root of 5a times square root of 5a gives me 25a squared And then square root of 5a times 3 is 3 times square root of 5a. So 25a squared, the 25 and the a squared are perfect squares. Square root of 25 is just 5, square root of a squared is just a. So I just brought that down. Okay, so if you notice, if you do square root of 5a times square root of 5a, you're multiplying something by itself, which means you're squaring it. So if you square a square root, you get just what's underneath, which was 5a. Okay, another way we can multiply is multiply binomials, and we'll use FOIL again. Okay, so remember FOIL is first, outer, inner, last. So first, square root of 2 times square root of 3. Those are both under the radical, so I can multiply them together. And then we want to do outer. Okay, 7 is not under the radical, so you just have to write it in front of the square root of 2. And then inner. Same thing here, the 6 is not underneath. And then last. 6 times 7, those are regular numbers, so I multiply them together. Okay, and then I would want to simplify if I could, meaning combine like terms, but none of these are like radicals. So really, this is my final answer. The only thing is you might see the 42 written in front, but pretty much this is all we can do. Okay, let's look at the next one. This would be a good time for you to pause and practice on your own. Okay, so if I do it first, I get square root 8x squared and then outer would be plus square root of 4x minus 9 times square root of 2x, and then minus 9. Okay, I don't have like radicals, but I do have simplifying that I can do. So I can simplify square root of 8x squared because I know that 4 goes into 8, and square root of x squared is just x. So this is 2 square root of 2 times x. So 2x square root of 2. Okay, this can actually simplify too because 4 is a perfect square. So that's 2 square root of x. Okay. No, nothing that can be simplified here. There's not a perfect square that goes into 2x, and then your minus 9. Okay, these look close, but they're not the same. They're not like radicals. And remember, what you're looking at is the numbers underneath. So square root of 2, square root of x, and square root of 2x. None of those are the same. Okay, we have one more to do. Okay, so square root of 3 times square root of 3 is square root of 9. My outer would be minus 4 times square root of 3. The inner would be plus 4 times square root of 3. And then the last would be 16. Okay, so simplifying square root of 9, well, that's a perfect square, so that's just 3. And then I see that I have, I'll go ahead and write these down again. I have like radicals, so I have like terms here, because they both have a square root of 3. But negative 4 square root of 3 and positive 4 square root of 3 is just 0. So those just cancel. And then I have regular numbers. 3 minus negative 16. So I'm left with just this, which is negative 13. So there's a special relationship between square root of 3 plus 4 and square root of 3 minus 4. Those are called conjugates, and we'll talk more about those later in this unit. Really what a conjugate is, it's the same thing except one is a plus and one is a minus. Okay, let's do Unit 9, Assignment 4.